So I moved it to Friday because by Friday you sort of like, you'll be more or less, you should be ready. Now, what happens if you don't have it ready Friday? Nothing. But I'm just giving you the sort of like the expectation. At that point you should be ready for the exam and you should be asking the final questions, right, before the exam. So if you're not at that stage, you're a bit behind, let me know how can I help you. You're already recording, right?
I am. I can stop
No,
if you
no,
need.
I want this to be recorded.
Okay.
Maybe because this is a message for the ones that don't show up for class. You know, when it's okay that we're recording the class and you can watch it later, but I want to make clear that this is not an online class. Okay, you are expected to be here. So the fact that we are recording the class is an extra step for your review. So that being said, I'm going to always prioritize the students that are here. So I have students that are not showing up at all, and they dare send me messages on Teams, you know, to configure the repos or whatever. So I'm sorry to say, but I reserve the right to gently ignore those messages. Because if you haven't given me a good reason for not being here, like being sick or whatever, so I will expect you to be here. Now, if you're always here and you send me a Teams message because you're working on your assignment, I'll try my best to answer to you, right? But if you never show up for class, and you send me a text asking to configure your repo or your micro, then you're so behind, and you haven't given me a valid reason for being so. So, I'm sorry, but yeah, I just wanted to say, I know that the ones that are in that situation are not here, but it annoys me a little bit being so busy that I get some students that will do that.
It makes it more difficult
Yeah.
for you and for them.
Yeah, it's well, everybody makes his own decisions. We do have our exam in a week from now, so feel free to ask me any questions or anything to go over. Anything in particular that you want me to go over? The stuff, sorry, before you ask any question, the exam will be timers, but basic timers, only up to update events. However, today, we will show you a demo on Output Compare, but that won't be in the exam. And the reason for doing that is because we cannot wait till you write the exam to start any content, because then the time is gonna be too tight. So we need to have time to work on the assignments and all that. So that's why we keep going with the content. Of course, we do have another class on Friday and another one on Monday. So on Monday, we're probably going to get the repos ready. So Monday is a bad day to be absent. So you wanna be here to configure your repository and to ask questions. And we could probably do some demo questions either Friday or Monday. Or if you bring up any question, I can also go over the things that you want me to go over again, okay? So that being said, anyways, any questions right now? Yeah.
So for ICA 6, I'm actually wondering, so not only are we looking at the flash latency specifically, but we're also looking at like the speed in which that the pin can fire.
Yeah.
I noticed in debugging that even setting the speed of the GPIO pin to high didn't actually change anything for iterating through all the different clock speeds. The only thing that seemed to work was to
Set it to very high?
yeah, it was just to like, we needed to just like, you know, clear the latency settings, you know, wait a couple of states and then enable the instruction prefetch, right?
Oh, yeah.
So in testing, I just noticed that setting the GPIO pin to high didn't adjust anything at all, because my application was breaking the moment it got to 64 megahertz.
Oh, yeah.
But the moment, of course, that we were able to, you know, increase the speed of, or I guess we're increasing the latency, which is allowing it to do what it needs to do.
I think I understand the problem that you're having, because I did experience it myself as well. And I'm gonna show you what I did.
Because the moment that I added the code for the flash latency, it was perfect.
Yeah. So
I'm just wondering why we would.
just to be clear, the GPIO speed has nothing to do with the flash latency. The GPIO speed is only needed when you want to see a high frequency signal on the pin. And which is why in assignment 6, if you notice, I asked you to divide the output by 8
Yeah.
for all settings. So you will never really have a signal that is higher than
8 megahertz.
Yeah, so you should be able to see it with the normal speed.
Oh, but if we were actually outputting the correct, like
If
if
you
we
were
weren't
not
doing a
divided, then
prescale.
you will have the problem. I did that on purpose. So you didn't have to worry, because I wouldn't like you to put the speed for the pin in the clock library, because I think I've mentioned before in the past that I'm not a big fan of hard coding things. And since you can have the clock output in PA8 or PA9 or some other pin, it doesn't make sense to hard code it. Okay, so whenever we need to output the pin without the clock pin, without dividing anything, we're gonna make sure outside that we set the speed properly.
Do you remember what speed in which, because I know it was Ohm that had brought this up like well over a week ago. Do you
Yeah.
remember what speed in which we required to have it set as the.
So very high.
Yeah,
I think anything above 40 megahertz was it?
it was?
Or
Okay.
48, yeah.
All right.
Yeah, and this, the same thing with the flash latency. Here's what happens. And this is why I had to integrate my flash latency here. So this is my clock library, and see my flash is in here. Okay, so I'm saying if any range is different than 16 or 20, do it, or 24, do it. And I do it before I do this other stuff, kind of in the middle. And the reason for that is because if you have this, let's say if you have this for your flash latency, if you were to insert this after you already have your clock, the moment that you run this line, you're clearing the settings for a moment, so you can write the new settings, right? So when you clear the settings, you're going back to the normal speed, no wait states.
Then I'm also noticing in this implementation here, we're not actually clearing that configure SW and then switching back to the PLL.
Oh, this one? Which one? This one?
Yeah, at the bottom here. So we're re-enabling the PLL at the bottom there, but I'm just wondering, like, if you were.
No, I have it here.
Oh, it's at the top.
Yeah, because at the beginning. Yeah,
Okay.
because I have to. That's the thing I told you. In order to disable the PLL, you need to disconnect it from the system clock first. Otherwise, it won't disable. See what I have? I disable PLL as system clock, and then I disable the PLL itself. There's two disables. There's one to enable the PLL as a system clock, so I undo that one first. So basically, I detach the PLL from the system clock, and only then I can disable it.
Yeah.
Now, you probably didn't notice this problem before, because when you start the code by default, the PLL is not enabled. So that works, but that's why on purpose I ask you to change on runtime through different clock speeds, because then if you didn't have that provision, it will get stuck eventually.
Yeah, it will.
Yeah. So, and for this part, since before I write the new settings for the flash, I clear them, for a moment in line 49, my flash will go back to 0 states. And if for some reason you're running at 64 megahertz and you run through that code, then it's gonna break it. So that's why this cannot be outside the clock speed. If we want it to be reliable, it has to be inside the clock speed, but it has to be sort of like in between before the PLL gets enabled.
Huh. Okay, because I just put this in the initialization portion of the ICA, and I'm still able to iterate through.
Well, if you do it before you, but here's where you're gonna have the problem. Here's what I'm trying to explain.
Yeah.
Let's say that you're running at 64 megahertz and you already have this setting because you put it somewhere, whatever, and it's working.
Mm.
The moment that you try to switch off 64 megahertz to a different setting, if you happen to disable this while your clock is at 64, then the latency goes back to 0 states and it's gonna crash because it cannot keep up with such a high speed.
Yeah.
So what you wanna do is you don't wanna have this line, basically, when the clock is running at higher than 40, 48. That's what I'm trying to say. And that could happen. So the best way to do this is to have it before they actually, you enable the PLL. But in between, sort of thing. Now, if you do this before you enable the PLL at all, it should also work. But if you're coming back from 64 and you do this, it's going to try to disable the flash when the system is still running at 64, and it may just hang there.
Okay, so then if we weren't noticing any hanging, then that could just be a coincidence, and it could eventually hang because of. Okay, all right.
Well, in my case, it was more evident because I had this after the clock init PLL.
Yeah.
And it was working fine until I started trying higher speeds, like 50 and 60 and 64. So basically, when I was scrolling through the array, when I hit 60, this will crash.
Yeah, mine crashed at 64.
Yeah, and it was because of that. So that's why I had to relocate this and put it inside.
Okay, got it.
So I'm assuming at this point, everybody has the clock library, right?
Clock library? Yes.
Yeah. I mean, with the huge sneak peek I gave you there, I mean, yeah. What else can I do?
Not a whole lot.
Everybody was like taking pictures like crazy. Yeah, I mean, at this point should be done. Okay, so any other question? We did last class a review of the USART and how we buffer and receive things, right? Okay. So, unfortunately, I don't have a lesson. I haven't had the time to put it for output compare, but I'll upload it this week. But I did explain in very simple terms, right, what output compare is. And I'm gonna go over it again. So far, we have our CNT counter, right? That's what the counter is. And so far what we've been doing is we've been just working with this UIF, right?
Yeah.
Update interrupt flag. So basically is when the counter rolls over. Either 65,535 or whatever number is in here, right? If you wrote 1,000, and it's gonna roll over at 1,000. Well, if you roll 1,000 minus 1, right? So that's kind of the way this works. So far we've been working with it. So what output compare does. So first of all, why is it called output compare? Is because, well, you perform an output operation, but you're actually comparing. And what are you comparing? You're comparing this guy or the counter against this guy. Now, when I say this guy, I refer to the capture compare register. And when I say that, I can actually go to my site to show you the lesson because that one is definitely there. In the introduction to timers, we do have this table, and this table is very important to understand how the timer works. So the basic timers, 6 and 7 that we've been using so far, they do not have any capture compare registers. Therefore, we cannot do any output compare in those timers. So we have to be careful. And timers 16 and 17, they only have one of those, and timer 15, 2, and so on. So you have to check this table if you ever want to do an implementation, and you have to make sure that the timer at least has a capture compare register. Since the timers are defined in a way of a data struct, you have to be very careful because the data struct will allow you to do things such as this. I'll show you. You could pretty much do timer 6, pointer to capture compare register 1, even capture compare register 4. But we know that capture compare register 4 doesn't exist for the timer 6, right? Because it has none. See? There's a 0 here. So that we have to be careful. The data struct will allow you to do whatever. This is probably going to give you an error if you try to write something in there because that memory location doesn't exist. Okay? Or you may be able to get along and write that, but it will just do nothing, right? Because it doesn't exist. Is that clear? So we have to be careful and check that documentation first. So then, depending on the timer, I'm going to have a capture compare register 1, capture compare register 2, and so on. So let's say we want to write a value in this register, and we write 400, for example. What's going to happen is that whenever this counter is 400, an event is going to be generated, but this is going to be a different event. and it's going to be an output compare event. And there's going to be a flag that we're going to check, but a different flag, okay? But it's going to be in the same status register that this one is in, because that's how the peripheral communicates with the software, through the status registers and flags, okay? Now, one of the things that is important here, if we want this event to happen every 400, let's assume that we're taking a 1 microsecond, which is the typical that we want to use because it's simple. So if we want this to keep happening at 400 microseconds, we need to keep rearming these guys. And the rearm refers to just doing this. Every time this event happens inside the if, we're going to do this so it happens within the next 400. So it happens at 400, 800, 1200, and so on. And it keeps happening, and even when it rolls over, it won't be a problem because of the unsigned mask, right? We proved that already. Now in this type of operation, normally we want to have the timer running at the full range. We don't want to cut it short, because since we're doing this rearming, it doesn't make sense to actually change the AR. Okay? Now the other difference with this is that with this output compare event, we can allow the timer to take over a certain pin. Okay? And those pins are fixed. And in order to look at that, we need to probably start with CubeMX. Okay, so let's go with STM32 CubeMX. And I'm going to open this sample that I have here. And in the meantime, I'm going to open, oh, I think I opened the wrong, oh no, this is the right. I'm going to open the documents for this thing, the reference manual, and the datasheet. So right now we have a few timers enabled. I'm going to disable them all. It's funny, this one is disabled. Okay.
Oh, you need to start a new.
Yeah, if you don't have this going, you need to start a new project. Oops.
Sorry, brother.
The way you can start a new project, I can show you here, so you can follow along. You go File, and you know what? Let's start a new project, because this one I've been using for a while. You do File, New Project. I don't care, I don't want to save this one. Sometimes it gives you an error when you're not logged in. You can just ignore that. And the best way to go around here is to check a board selector, because otherwise you're gonna see like hundreds of different micros in there. And this is annoying because I'm not logged in. I'm not logging in because I don't want to. In type, you're going to select Nucleo 64 because our board is a Nucleo 64. In MPU series, you're going to select the G0 because our micro is an STM32 G0. Once you select the G0, you only have 3 options, and your board is the last one, is G0B1RE. You double click, and it's going to initialize everything by default. All right, once you have this, let's say that you want to use timer 16, which has 1 capture compare register, right? So I can only use, when it has 1, obviously it's capture compare register 1, okay? Still working on trying to bring it up? Which part are you? Let me see.
Making sure that it's the correct board.
Is it? Yeah, it's the correct one. You just didn't initialize things as default. That's why you don't see the other
So
So
when
when
you go to close this, just save this configuration, and you can open it back up the next time you open up the application.
Okay. So
Just save it somewhere.
I'm going to go here to timers. I select timer 16 and I'm going to say activate. And then I'm going to enable channel 1 as an output compare, CH1. And that's going to bring up a pin. Okay? And it showed me here PA6. And that's a convenient pin. I think I'm going to leave it there. It could be connected to also a PB8 or PD0, but I'm going to leave it on PA6. PA6 is just below PA5. So that means that I'm going to have to search for an alternate function for PA6, right? So we're going to go to the datasheets and look at the alternate functions. PA6 should be in here. And PA6, which one is the timer 3? No, timer 16, sorry. It's right here. Timer 16, channel 1 for PA6. That is alternate function 5. All right. So let's go to the code.
Still on the lower register.
So what is the first thing I need to do, even before the alternate function? Carl will know. I'm pretty sure he will know. What is the first thing I need to do to use any peripheral?
Enable its clock.
Enable the clock for the peripheral. So that's what I'm doing here. See, timer 16. That's very important because if we forget that, nothing will work. Then, aside from my user that I have here, I'm configuring my regular LED and button, but the timer configuration starts here. In this particular case, for some reason, I use PB8, but I'm going to change this, okay? We said we were going to use what?
PA6.
PA6, timer 16, channel 1. And so that's PA6. And its alternate function what?
5.
5. So I'm going to change this function to GPIO A. And then 6. And its alternate function 5. So that should configure it. Okay? Good. So that is the clock. So maybe we should state all the steps here. Step 1. Let's just put it in here. I'm going to write out the whole thing. Step 1, enable timer 16 in the RCC, okay? And that is in line 50, okay? Second step would be configure alternate function, right? For pin. We will know what we'll do with the pin in just a moment. So that is right now, I'm not going to put the line yet because it's going to keep moving, okay? What do you think is the third step? We're still using a timer. So the preliminary configurations for any timer, they still apply. So we're going to basically set the tick time. So basically the prescaler, right? And ARR, which is the period for the auto reload. So, and all that is in here. I'm going to set that this is step 3.
To prescaler.
And this is also step 3. Okay?
And then you're giving it a range of 65, 535.
Yeah, maximum range. Okay. So then, what I'm going to set here as a fourth step is going to be configure time event for the first time. So that one is happening here. Okay? So that means writing to the capture compare register 1.
Okay, that's something we haven't technically done yet.
No, we haven't done it.
Got
Yeah,
it.
so that's what I'm saying, that I'm gonna put that on the lesson, but right now, basically, is what I wrote there.
Yeah.
So I need that so it happens the first time. Okay. So the second step, some of these steps are interchangeable, right? It's not necessarily in this order, but we can show you later what is really relevant. What is really relevant is to enable the timer at the end, to make it count at the end, once everything is configured. So the second is going to be enable output compare channel, and I'm going to set here, put in brackets the register that needs to be targeted for that, and that one is the CCER, okay? We're gonna take a look at where the CCER register is. Reference manual. The timers are set in groups because the timers are similar, are in actually the same chapter. So timer 15, 16, and 17 are in chapter 25. If we go to these registers, we will find CCER. And CCER says the following. It says capture, compare, enable register. So don't worry too much about these other ones. The only one that we need to enable is CC1E. And let's take a look at that one. So if it has a 0, which is the default, it says capture mode disabled, but OC1 is not active. So OC1 not active means that it will do nothing, right? Then a 1 says capture, compare, capture mode enable, or OC1 signals its output on the corresponding pin. Now this may seem a bit confusing, and the reason for that is because the registers serve two purposes, depending on if the timer, the channel, is configured to actually output compare or input capture. We're not doing input capture till next course. So we're doing output compare, and I'll show you actually later. Maybe I should do the set to output compare first, and then this one will make more sense. But assuming that it's output compare, I'm going to look at this part, not the first one, because this one refers to input capture. So OC1 signal is output on the corresponding output pin. If it's 0, OC1 is not active, so it will do nothing to the pin, the alternate function that we're setting. So we need to write a 1 here. Now, see how this timer has only CC1E. Let's go for a moment to timer 15 registers, and let's try to locate the same one, CCER. And it happens that timer 15 has CC1E, but it also has CC2E. Can anybody tell me why?
Because that one's going to be, that one has two capture
Has
compare
two channels. Excellent. So we go back to the site. Timer 15 has two channels. See, it makes sense. So it has a CC1E and a CC2E. Whereas this other guy here, let's go back to this one, has only CC1E. See? Doesn't have a CC2E. Then the ones that have 4 channels, we'll have a CC3E and a CC4E. Okay, so we're going to enable this CC1E, and this is enable output compare channel. Basically, connect OC1 to pin. And that's going to be number 5. Which doesn't make a lot of sense, to be honest. I think it should be this one first. Okay, so then after that, we're going to configure something. Set output compare action. And that happens in the CCMR1 register. what is the output compare action? Let's take a look at this CCMR1. And now here we're gonna get more confused. And that's why I need full attention here. Because as you can see in the reference manual, and I'll explain this in more detail when I write up the lesson, we have two CCMR1. One here and the alternate. So which one do I use? Well, first, I need to tell you that there's one for input capture and there's one for output compare. And they are slightly different.
Input capture is going to be your IC1.
No, input capture is, next term. Output compare is what we're doing now. Yeah.
No, it looks like when we look here, we can see where the input capture mode is.
Yeah, so how do you distinguish? You read here. That's one way you can do it. It says the same register can be used for input capture, this section. It means that this section is input capture. So that's not the one we want. I go to the next one. It says the same register can be used for output compare, this section. So this section is output compare. Basically, it would be easier if it said there, this is output compare section. But I think they wanted to recycle the text from the previous one and they just added this section part. So this is the register that we're looking at. So now we have some configurations, but the OC1M is what we care about. And look at all these configurations here. We have 4 bits that get configured. And by default, 0000 means frozen. The comparison between the output compare register and the counter has no effect on the outputs. So meaning that it's going to do nothing. On the output, I just want to be clear that this event will still happen and you will still see the flag, you will still be able to clear it, you will still be able to toggle an LED manually. But that's not what we want. We want the timer to take over the pin, which is why we are setting the alternate function, okay? So, then if we take it out of frozen, we can set it to active high or to something whatever, but the easiest thing to test is to do the toggle. So we want to do the toggle, so we're going to see the pin toggling. Pay special attention to what's coming very soon. PWM mode 1, PWM mode 2. This is what we're going to be using for PWM. We're not there yet, we're just doing output compare, so we're going to do toggle. So that means 1 and 1 on bit 0 and 1 of that bit field. So what I have in here is an OCM. Oh, I'm not clearing the settings here.
Not yet.
Interesting. Let's clear the settings for this guy. It's a good practice to always clear the settings first, right?
Anything we set up, just clear it first in case it was set to something.
And it's the OC1M. Clear OCM1 settings. And as you can see, this mask has a 7 bit shifted by 4. Well, it has also a 1. So basically, it's clearing these 3 bits because I believe that the most significant one is not used. That's why. So it was always 0.
No, it's just 3 bits.
Is it 3 bits? Oh, why does it show 4 then?
It's interesting, yeah.
Oh no, because it goes from 3 to 0. Oh no, it's in. Oh, where is it?
Yeah, because the OC1M there, you can see.
Oh no, it's here. See, this is even more confusing. Yeah. The 3 least significant bits are here, and there's another one here.
Why?
I don't know. No, I think I know why. Because they want to use these other ones for OC2M, OC3M, and all that. So they want to keep it consistent. So that makes it very complicated.
So you'd have to write also to.
Yeah, but you don't. But this one is always 0, so you don't have to worry about that one. It will be always 0. But to clear it, the mask will take care of it. See, the mask. If you hover the mask, oops, where is it? Here. it has the 7 for the 3 bits, but it has a 1 also here.
Interesting.
And that's on the bit 16, see?
Yeah.
The first 3 digits is 12, this one is 16.
Yeah.
Yeah, so it's very tricky. So it is there. Yeah. So then I write the settings with this, right? So the bit 0 and the bit 1. But you can also do this. I show you another way of doing it. If you are more comfortable with the binary, you can always bit shift by this guy underscore pause. The underscore pause
Is the
holds the
position.
position, basically the bit shifting that you need to do.
And it makes a little more sense because you are writing 1-1
Yeah,
specifically to enable the toggle. So
yeah. In some of the cases when we first started this course, you guys were using this number manually, right? You were just looking at the register and then you were putting a 24 or whatever number needs to be put there. So this one can also be used. If it makes more sense to you, doesn't matter. So right now this thing is set pin action to toggle. Okay? That is number 6. This is also part of number 6. All right. Then step number 7 and last one, second last, enable master output, and that happens in the BDTR register.
that sounds very important.
If implemented. Here's the thing, this is another quirk of this micro. Not all the timers need this master output enabled. So for example, when you look at timer 14, do we have a timer 14? Yeah, timer 14 is a very simple one. This one. And if you look at these registers, it doesn't have that register, the BDTR. So it's not here. See? Can you find it? Yeah. So I think timer 14 is the only one that doesn't have it, because timer 15 has it, BDTR here. And we're using timer 16 and 17, and also that one also has it, apparently. See, here. So, in most cases, you will need it. I'm going to put here, needed in most cases, not timer 14. For some reason, timer 14 is a simple timer and it doesn't need it. Of course, timer 6 and 7 won't need it either, because the master output enable doesn't make any sense with those, because those don't connect to any output, right? Yeah, so far I've been seeing that most timers need this. And you know what? If you don't do this one, nothing works. I mean on the pin. So that's very important. That's number 7. And lastly, number 8, guess what? What is number 8? Start the timer.
Finally.
This is number 8. Number 8. Okay.
CR1, CR1 CEN. Yeah.
Now, to check the flag, let's go to the flag, to the status register here. Status register should be named SR here. And as you can see, this one also has the update flag that we were using so far. In fact, if we go back to timer 6 and 7, and we go to the registers, this one is much simpler. See, that's why we started with this one. You go to the status register here, and this one is all grayed out. See, only this one, because that's the only flag that we have in that timer, because it's basic. Whereas in this one, we have more. Ends, I lost it here. So we got some other ones that we're not going to worry much about for now, but we could use this one, or we can also use the update, but in this case we're seeing output compare, right? So we're gonna look for this flag. So when this flag becomes active, we're gonna check it with this. In case you didn't notice, I haven't been using any library here. I've been doing everything from scratch, so I can show you how to do it. When does this flag get activated? Here, when the counter equals the value that you put in here, this flag will get activated. That's exactly what we're checking here. What do we do after? We clear the flag,
And then
we
you,
rearm the event, so now happens at the 800. And we manually toggle PA5. That is just for testing purposes. So I'm gonna hook up to PA5 on the scope and bring up the camera. Ends. Oh, this one here. I don't think I'm running this actually. Let's run it. .400 microseconds.
it's a very clean signal.
Yeah. Even though I'm doing this with software. In fact, what I'm gonna do now, comment it out. What do you think is gonna happen? Well, the signal is gonna be gone, of course. No more signal. What am I going to do here now? I'm going to connect this to the pin that is right below, which is PA6.
Which is the one that we've configured for the
Exactly.
Timer
See,
output.
you're following me.
The
Connected.
timer 16.
There we go.
Because you configured it on PA6, so now that we can have it as a hardware control instead of a software control.
Exactly. So the big difference here is that the software is not toggling this pin, it's the timer itself that's doing it. Okay? So there's no actual toggle anywhere in the code. All we're doing is just rearming this. Now, if for some reason you forgot to rearm and you just clear the flag, what do you think is gonna happen? You're going to see the evil number. The evil number is the one that you have to remember always, because if you ever see this evil number, especially in an exam, means something bad. 65 milliseconds.
65, 535.
Yes. This happened here, and the timer says, see you later. See you tomorrow.
I'm by. Yeah.
That's why you see that. Well, the timer is ticking at 1 microsecond, right? But if you rearm it, it will happen with no problem. Now, what I'm going to ask you to do is work with this demo. You can work with, do this at home or right now. It's up to you if you want to work on the assignment. I think I'll just cut it here.